Hello everyone. I am the instructor for this class, Ningbo. Next, I will introduce the course Petroleum Refining Production Technology. My introduction covers the following aspects: course positioning and function, course design philosophy and approach, organization and selection of teaching content, teaching methods and means, course features, and course unit design, making 6 aspects in total. First is the course positioning and function. Through extensive research on the petroleum refining industry and typical enterprises, it has been determined that this course targets positions such as operator, promotion positions, and technician roles. The course serves the regional chemical industry chain, using typical products from petroleum refining enterprises as the carrier, and the production processes of these typical products as the main thread. It focuses on cultivating students' learning and mastery of the characteristics of raw materials and products, typical petroleum refining processes, production process principles, workflow, analysis of process control factors and implementation strategies, equipment operation methods, as well as knowledge and abilities related to these issues. This course is a core course in the Applied Chemical Technology major, occupying a central position in the talent cultivation process. Prerequisite courses include chemical application technology, chemical unit operations and equipment, etc., enabling students to master basic professional knowledge and skills. Follow-up courses include organic chemical production technology, etc., serving as an extension of petroleum refining processes. Concurrent courses include chemical engineering drawing and CAD, etc. The training objectives of this course include knowledge objectives, ability objectives, and quality objectives. This defines the training specifications of the course. Second is the course design. The course design philosophy includes 2 points. First, a course design featuring fragmented information design, systematic structure, and resource sharing. Based on the sequencing of work processes, teaching content uses knowledge points and skill points as carriers, forming massive fragmented resources and resulting in a systematic course design. The course will be built into a high-quality resource platform that is open and shared. Its functions include not only the learning of enrolled students, but also the training of personnel from partner enterprises and self-directed learning for the general public. Second, the teaching philosophy emphasizes self-directed learning, personalized learning, and lifelong learning. An interactive online course will be developed, fully leveraging the capabilities of modern big data and information technology. This aims to stimulate students' enthusiasm and effectiveness in learning, achieving self-directed learning, personalized learning, and lifelong learning. The design approach of this course is as follows. 1. Close alignment with job positions. Schools and enterprises jointly build teaching projects. Together with professional technicians from Dongying Fuhai Group, a pilot enterprise for the modern apprenticeship system, typical work projects and work processes are identified based on an analysis of the professional competencies corresponding to the course positions. This refines the typical work tasks for refinery positions, such as gasoline production. 2. An integrated teaching system connecting online and offline, inside and outside the institution. Technical skills are enhanced through alternating cycles of learning, practical training, and internships, achieving education through job roles. A dual mentor system is implemented, jointly building 3 platforms: on-campus training, off-campus training, and remote training. School enterprise training resources are co-developed and shared. Third is the teaching content. Based on conducting professional research, enterprise job content is introduced into classroom teaching. Schools and enterprises jointly establish a dual mentor teaching team and co-write characteristic textbooks integrating work and study. This involves co-construction, co-management, sharing, and mutual benefit. The construction of a practical training system integrating virtual and real elements is carried out in 3 aspects. The typical refinery process, gasoline production, from the typical petrochemical enterprise Dongying Fuhai Group is selected. Together with professional technicians, based on the analysis of professional competencies corresponding to the positions, typical work projects and work processes are determined. Typical work tasks are extracted. An analysis of job professional competencies is conducted, forming 6 major teaching projects. Respectively, 1. Crude oil evaluation. 2. Production of straight-run gasoline. 3. Production of catalytic cracking gasoline. 4. Production of reformed gasoline. 5. Production of coker gasoline. 6. Refining and blending of gasoline components. Project-based teaching is implemented according to the actual work processes of enterprises. Course content is selected based on the production processes of typical enterprise products. This course is designed with 6 teaching projects and 11 work tasks, totaling 102 class hours. Additionally, for enterprise practice projects are interspersed. The course's on-campus practical training reflects the alignment with enterprise job positions. It follows the alignment with professional standards. Importance is attached to alignment with skills competitions. This constitutes a comprehensive practical training module. Looking at the practical training modules of the entire course, each learning project includes on-campus training and interspersed enterprise training phases, forming a progressive, accelerated competency-building sequence. School-based textbooks are compiled jointly with enterprises, serving both as learning materials for enrolled students and as training tutorials for enterprise employees. Schools and enterprises jointly revise them to ensure the specificity, richness, and timeliness of the cases in the textbooks. The assessment for this course focuses on skill evaluation, supplemented by theoretical assessment. During the assessment process, attention is paid to evaluating student qualities. Fourth, teaching methods and means, constructing an online plus classroom, on-campus plus enterprise teaching model. Means such as online teaching and virtual teaching are introduced. Students engage in self-directed learning through the online learning platform. In theoretical classes, students are the main body, and teachers play a leading role. Integrated theoretical and practical teaching is carried out, stimulating students' interest in learning. Allowing students to learn independently in an information-based teaching environment. Constructing a learning model that is active, in-depth, and expanding. And an online plus classroom, on-campus plus enterprise teaching model. Fifth, course characteristics. The characteristics of this course are manifested in 3 aspects: fragmented course resources, multidimensional teaching activities, and an expansive practical training system. First, a massive amount of fragmented resources, mainly in the form of micro-lectures, has been formed to enrich the course content. Second, an active, in-depth, and expanding learning model and an online plus classroom teaching model are constructed. Third, on-campus simulated operation training is interspersed with enterprise awareness internships and job shadowing internships, effectively expanding the scope of practical training and hands-on ability for enrolled students. Finally is the unit design. Below is the unit design for the lesson on catalytic cracking reaction regeneration process operation. First, clarify the ability objectives and quality objectives for this lesson. The teaching steps include a pre-class online preview phase, an in-class integrated teaching learning doing phase, and an extracurricular enterprise practice phase. In the pre-class online preview phase, student self-study is primary, and the teacher is responsible for providing online materials for student self-study. In the in-class integrated teaching learning doing phase, the first step is organizing the teaching and introducing the content. In the in-class integrated teaching learning doing phase, course learning includes not only classroom teaching but also extracurricular practical teaching. The content primarily involves learning by doing, specifically including enterprise practice stages, post-practice, shadowing, and internship, integrating teaching, learning, and doing. Through the various interwoven links both on and off campus, combining theory and practice, students acquire the necessary knowledge, abilities, and qualities. The above is the basic information about the Petroleum Refining Production Technology course. Goodbye.